Now let's look at solving some real-world rational inequalities. It says that Carpenter is making tables. The tables have rectangular tops. This is key, knowing the shape, with a perimeter of 20 feet and an area of at least 24 square feet. Write and solve an inequality that can be used to determine the possible lengths of tables. So here's how you do this. First, you need to write out the equations. Now remember, perimeter for a rectangle is 2 times your length plus 2 times your width. The area for that same rectangle is length times width. So how we're going to solve these is we're going to plug in some information and substitute one equation into the other. So what do we know so far? We know that perimeter is 20. So 20 equals 2L plus 2W. And we also know that A equals 24. Now, one thing I can see up here is we could GCF this. We could simplify everything if we just divided everything by 2. I'm left with 10 equals length plus W. So how can I use that to help me solve the equation? Well, I just substitute. If let's say I want to get L by itself, I could rewrite this and say that L is equal to 10 minus W. And now I can substitute that into this equation. So let's do so. We have 24 equals, but instead of saying L, I'm going to say 10 minus W times W. Now there's my equation. And I think I just said we want the area to be at least 24. So we actually want the area, it can be 24 or it could be bigger than 24. So the area, since it can be bigger than 24, opens away from it. 24 is the smallest it can be. So now when I substitute in, this equation also needs to stay as like this. Now this is my write and solve an equality. So this is my inequality here. Let's box this up so we don't get lost. This is my inequality that could be used to solve the problem. And now let's determine what the links are by going to our graph. So I would go over here, new document, and so we'd say that 24 is one equation. The other equation is going to be 10 minus x. Now we're going to multiply that times x. Substitute x in. And now I'm also, after I graph this, I'm going to go menu, analyze, not menu, I'm going to, menu, zoom, settings. Now I know they're going to hit a 24, so I want to be able to see above 24, so I'll just put in 30. So there it is, and I want to know the intersection. So menu, analyze graph, I'm going to look at the intersection here, and I'll do the intersection again to get this value. Now I got my answers, and now I can see that the width for the equation to be above or equal to, it needs to be somewhere between 4 and 6. So my width needs to be between 4 and 6. And if I'm going to have a perimeter of 20, the other side will be the other length. So if this was 4, then the other one would be 6. Or if it's somewhere in between, you could just average them out to equal 20. So that would determine the other. So you can use that as well. That would be your width, or your length is anywhere in between those two values. Let's try another one. It says Eric can paint a house in 6.5 hours. Peter can paint the same house in 6 hours. If they were to hire a third painter, how fast must they paint to paint the house together in less than 2 hours? So here's your equation. So this is rational because it's kind of like doing your job dividing by the time it takes to complete the job. So we have one painter doing the job in 6.5 hours. We have another painter doing the same job in 6 hours. We have a third painter. We don't know how long it'll take them, but we do know that together, which means if we added these up, they want to do it in a smaller amount of time than 2 hours. Smaller amount than 2 hours. So this would be the bigger amount. This would be the smaller amount. So now we just graph these and look at our solutions here. So go new document, graph, and I'll have the left side equation, which is 1 over 6.5. And then we're going to add that to 1 over 6 hours. And then the other one is going to be 1 over some unknown amount of time. And then we're going to have a second equation, and now we want that to be 1 over 2. Now as I look at these, I'll have the solution where their intersection. And that's how we would come up with what speed he must paint the house to get it within. So if this person is able to paint the house within 5.57 hours, then it would work. So x would equal 5.57 hours. And if you wanted to convert that to minutes, all you'd have to do is take 0.57 and times that by 60, and that's how you could get that as a better time than just 0.57. Now you try this one.